Imagine a world where you could create almost anything you can imagine, right in your own home. This is the promise of three-dimensional printing, a technology that has rapidly evolved from a niche hobby to a transformative force in manufacturing, medicine, and beyond. Three-dimensional printing, also known as additive manufacturing, is a process of creating three-dimensional objects from a digital file by building them layer by layer. This revolutionary technology has the potential to reshape industries, empower individuals, and solve some of the world's most pressing challenges. From printing personalized prosthetics to creating complex architectural models, three-dimensional printing is blurring the lines between science fiction and reality. In this exploration, we will delve into the fascinating world of three-dimensional printing, examining its inner workings, its diverse applications, and its profound implications for the future. The journey of three-dimensional printing began in the 1980s with the invention of stereolithography, a process that used lasers to solidify liquid polymers. Since then, the technology has advanced at an astonishing pace, with new materials, techniques, and applications emerging all the time. Today, three-dimensional printers are used to create everything from toys and jewelry to medical implants and aircraft parts. As we venture further into the 21st century, three-dimensional printing is poised to become an even more integral part of our lives. It has the potential to revolutionize the way we manufacture goods, deliver healthcare, and even produce food. The possibilities are as limitless as our imaginations. At its core, three-dimensional printing is a deceptively simple process. It all starts with a digital three-dimensional model, which can be created using computer-aided design software or obtained from online repositories. Once you have your digital blueprint, you need to feed it into a three-dimensional printer. The printer then slices the model into thin, horizontal layers. Imagine slicing a loaf of bread into very thin pieces. That's essentially what the three-dimensional printer does with your digital model. Each slice represents a layer of the final object. The three-dimensional printer then uses a specialized material, often a type of plastic filament, to build your object layer by layer. The printer's extruder heats the material and deposits it precisely onto the printing bed, following the instructions from your digital model. As each layer solidifies, the printer moves up by a fraction of a millimeter and deposits the next layer on top. This process continues until the entire object is complete. Different three-dimensional printing technologies use different methods to deposit and solidify the material, but the basic principle of building objects layer by layer remains the same. The result is a physical, three-dimensional object that precisely matches your digital design. Beyond its manufacturing prowess, three-dimensional printing is making remarkable strides in the culinary world. Imagine a future where you can print personalized meals tailored to your dietary needs and taste preferences. This futuristic vision is fast becoming a reality thanks to advancements in three-dimensional food printing. Three-dimensional food printing involves using edible materials such as pastes made from vegetables, meats, or even insects to create customized food products. The process works similarly to other types of three-dimensional printing, with the printer depositing layers of food material to build intricate and delicious creations. One of the most exciting applications of three-dimensional food printing is in the realm of personalized nutrition. Imagine printing meals with precise amounts of vitamins, minerals, and macronutrients tailored to your individual health requirements. This technology could revolutionize dietary management for people with diabetes, food allergies, or other health conditions. Three-dimensional food printing also holds immense potential for addressing global food security challenges. By utilizing alternative protein sources such as algae or insects, three-dimensional printing could offer sustainable and efficient ways to produce nutritious food for a growing population. Section 4. The Future of Food, Sustainable and Personalized Nutrition. As 3D food printing technology matures, we can envision a future where restaurants and even home kitchens are equipped with these culinary marvels. Imagine printing out a plate of pasta with a design as intricate as a work of art, or creating personalized pizzas with toppings arranged in your initials. Beyond the novelty factor, 3D food printing has the potential to transform the way we think about food production and consumption. It could enable us to reduce food waste by printing only the amount of food we need, and to create more sustainable food systems by utilizing alternative protein sources and reducing reliance on traditional animal agriculture. Moreover, 3D food printing could empower individuals to take control of their nutritional intake. Imagine printing out snacks fortified with vitamins or creating meals with specific calorie counts and macronutrient ratios. This technology could revolutionize dietary management for athletes, people with specific dietary restrictions, or anyone looking to improve their health and well-being. The possibilities of 3D food printing are vast and still unfolding. As the technology continues to evolve, it has the potential to reshape our relationship with food and create a more sustainable, personalized, and delicious future for all. Section 5. Printing Human Organs, a Biomedical Revolution. Perhaps the most awe-inspiring application of 3D printing lies in the realm of medicine, where it holds the potential to revolutionize healthcare as we know it. Imagine a future where patients suffering from organ failure no longer have to wait anxiously on transplant lists, their hopes hinging on the generosity of others. This future is edging closer to reality thanks to the remarkable advancements in 3D bioprinting, a field that focuses on using 3D printing technology to create living tissues and organs. 3D bioprinting involves using a specialized bioink made from living cells and a biocompatible material that acts as a scaffold. The printer deposits layers of this bioink, mimicking the intricate structure of human tissues and organs. Scientists have already made significant strides in bioprinting, successfully creating functional tissues such as skin, cartilage, and blood vessels. These bioprinted tissues hold immense promise for treating burns, repairing damaged cartilage, and even replacing diseased blood vessels. The ultimate goal of bioprinting is to create fully functional organs for transplantation. While this remains a formidable challenge, researchers are making steady progress. They have successfully bioprinted miniature versions of organs like livers, kidneys, and hearts, known as organoids.